In calculus, we learned how to take derivatives of functions that just have one variable. So for example, if we had a function f of x equals 3x squared, the derivative of this function with respect to x is simply just 6x. Another example is suppose now we have a function in terms of y, so we have f of y equals y. The derivative of this is simply just equal to 1. But now what if instead we had a function f that was in terms of both x and y, and we wanted to take the derivative of that? What do we do? The answer is we can take what's called a partial derivative, where functionally what we do is just take the derivative like we know how with respect to our specified variable and treat all other variables that may be present as if they were constants or just numbers. So, for example, suppose we had a function f of xy equals 3x squared y, and I wanted to find the partial derivative of this function with respect to x. What I do is I just take the derivative of 3x squared times y with respect to x only and treat this y as if it was just a constant, equivalent to what I do with the number 3. So taking the derivative with respect to x is just 6x, and then the y is just there. If I want to take the partial derivative of this function with respect to y, I do the same thing, this time pretending that the variable x is a constant. So 3x squared is a constant with respect to y, and taking the derivative simply becomes 3x squared times y. Let's see another example. Suppose, for example, now we have a function f of xy equals 3x squared minus y. Again, my partial derivative with respect to x is just going to be 6x squared minus 0, because the derivative of this term with respect to x is just 6x, and the derivative of this term with respect to x is just 0. The partial derivative of this function now with respect to y is 0, because there's no y's here, minus 1, because that's the derivative of y with respect to 1.